Hello everyone, in this video I'm going to show you some trigonometric proofs using complex notations for trigonometric functions. First, we will start using by Euler's identity. Euler's identity, as it's usually stated and called the most beautiful mathematics formula, states that e to the I pi is equal minus 1, or more generally, e to the I theta is equal cosine theta plus I sine theta. Therefore, we can derive cosine theta as e to the I theta plus e to the minus I theta over 2, and similarly for sine we can write e to the I theta minus e to the minus I theta over 2i. The first identity we are going to prove using these notations is sine 2x plus cosine 2x is equal 1. So in order to show that, we are going to rearrange them as their complex notations, and notice that given that I to the 2 equals minus 1, the exponential terms cancel each other, leaving us with only 4 over 4, which is equal 1. The next formula is the derivative of each of these trigonometric functions. Rearranging them as their complex notations, we realize that the only step necessary to take the derivatives is to derive the exponential function. And in this formula, the derivative of exponential function is only itself times I or minus I. As you can see, we have proof that cosine x is derivative of sine x, and minus sine x is derivative of cosine x. Here you can note that if you do these steps another time, you will get that minus sine x is equal minus cosine x after deriving, and minus cosine x is equal sine x after deriving. So we can notice a homomorphism from derivatives of sine x to multiplicative group of imaginary number I. So that's another way to think about this connection. The next identity is for sine 2x and cosine 2x. Again, we can rewrite them as their complex notations and use some algebra to open them up into the sine x and cosine x, as you can see in the picture. A bonus panel here is that you can use this formula for and inputs I theta, so a purely imaginary number, and fitting them, you can notice that sine I theta would be equal e to the minus theta minus e to the theta over 2i. That's equal minus 1 over I sine hyperbolic of theta, or shin theta, which is equal I times sine hyperbolic theta. Similarly, for cosine I theta, we have e to the I times I theta plus e to the minus I times I theta over 2 is equal e to the minus theta plus e to the theta over 2. That's cosine hyperbolic, or cosh of theta. Thank you for watching.